Hi, and welcome to MasterbendCAM. My name is Fred Cook. I'm the System Sales Manager for Premium Power North America. This is quite an extensive tutorial on MasterbendCAM. We're going to go through pretty much all of the features. Down below, you'll see timestamps that you can jump around from one portion to another. Feel free to pause and rewind and slow down the speed of play if you need. You'll also see I've got my mouse button inputs and keyboard inputs are going to be here, so you'll be able to follow along. Let's get started. Here's MasterbendCAM. So in MasterbendCAM, after it's been installed, we've got a few things to take care of at the very beginning. You can go to File, and Preferences, and there's just a few things you might want to change here for your own personal tastes. But to start with, as far as the programming goes, you have the option to have automatic enter compacted. What that means is that any parts that have flanges on them that are coming in, the tooling will contract itself before starting that side of the panel. It's a nice option to have and have it already turned on. And another one is automatic reposition. So if the software determines that it needs to reposition the gripper, that can happen automatically. You can turn both of those on and off depending on the type of parts that you're programming. Another thing you might want to change are the colors. So the background colors, it's just personal taste, whatever kind of environment you like to work with. I've got different colors here. You can just change and pick something else, and you can see that it changes your background colors. So we can fix any of that. Okay, I like blue. And next thing we might want to change then are your simulation settings. And if you scroll down here, you'll see simulation refresh frequency and simulation precision. And this is down to the speed of the PC that you're running. If you've got a low-end computer, you might want to change these settings down to very low, medium, high. Medium works great for pretty much everybody. If you've got a high-powered processor, you could take it up to very high. And what that means is just the smoothness of the animations that we see when we're simulating our bending programs. So at the moment, I've got both of these set very high. It's working quite well. And another one you might need to change, you can always run the machine in metric or inch, depending on what your setup is in your factory. And you may want to change the unit of length here, millimeters, centimeters, meters, or inch. So I've got mine in metric today, and we've also got a length of precision. So this is the number of decimal places that you'll see when we're measuring parts or moving any of the axes of the machine. 2 is good in metric. For inch, you might want to set that to 3 decimal places. So that's about all we really want to touch in here. Your applications trainer will help you with any other settings that are needed. You need a part to start bending. So in the description of the video below, there'll be a link to a Google Drive folder where you can download all of the solid models that I'm working with today. We're also assuming that you have NCX installed. You're either processing blanking machines from us, or you've got the Unfolder. If you just have a bender from us and you want to work with solid models, you'll have the Unfolder. So what we have here is NCX, and I'm going to grab my folder, just drag it into place here into the screen. And what we can do here, these are solid models from Autodesk Inventor. We can drag and drop them into the work area of NCX. So we're going to start with a simple 4-bend part right now. We'll drag it, drop it in. So here's our part. It's a simple 4-sided part. And what we can do here, we'll select the part and convert it to sheet metal. When we've converted it to sheet metal, over here in the tree, we'll see that we've detected the bends and what the base face is. And in the bends, if any of those are highlighted on the right-hand side, we'll see some information about the bend. It's a 90-degree angle, it's got an inside radius that's set by rules. And from here, we can then unfold the part. Now, what it's assuming is that the blue surface here is the top of the sheet as we're punching it. So if you've got parts that are sensitive to what side is up and what side is down, at this point you may want to change the top side. So here I'm saying that the top side, or the good side of the part, in terms of sheet metal processing, is the inside of the panel. And again, if I hit the change top side, now the top side is the outside of the panel. So that's something to pay attention to. In the metadata of your solid models, you can actually write a metadata tag that will force that to change automatically. Once we've unfolded the part, we just come to File, and we can see our model, or our flat pattern. Here we'll have bend lines. If I select the bend line and right-click on it, I can then look at the bend info and see that it is a bend line. It's got a bend angle and a radius and a K factor, and we're automatically calculating the bend deduction. So that's okay. Next step is to export that part as the file type that we need for MasterbendCAM. We go to File, Export, and it should use the same file name as the solid model that you just dragged in. And here we can just hit save. I've already got my parts, so I'm not going to overwrite them. So we're ready to go. Now we come back to MasterbendCAM. So next step for us is to do File New. I will just go through the buttons here real quickly once we bring in the solid model or bring in the part file. So the next step is to do a new part. So File New. Here you'll be able to work with different part types. We do have PCEs, that's a separate video, and PFP files. That's the file we exported, is a PFP file. Next step is to pick the bender. Depending on your installation, you'll most likely only have one bender in here, possibly two. If you're running demos, you'll have as many benders as you like in here. We'll have all the models for you. So I'm going to select my bender 2720, left loading. And then I'm going to highlight or select the part that I want to bring in. So the simple 4-bend part. Now here you can scale up your window and you can drag the splits around if you want a better view. In the preview screen, we can look at the part in different preset angles. So we've got a front view, a back view, right, left, top, bottom, isometric. Also possible to have a kind of a see-through part if you wanted to see some features that might be hidden. Wireframe is here, or solid shaded. This button will reset the part to view in the center, like a view all. We also have a measuring tool here. So with this measuring tool, we can take dimensions of the parts, for instance, and from snap point to point, and it'll give us dimensions. So it's quite a useful tool. We'll see some of that later on. So once the part is selected, we're ready to go. We just say OK, and it's going to ask us a couple of questions. First question here is going to be select the base face. Now it automatically selects the base face of the part, but if it didn't for some reason, you could force it to select a different face to say which is the base face. Obviously for this panel, the base face is going to be the main base of the panel. The other thing we can do, maybe your part came in upside down, and it's possible to correct that here. So here the part is base face with all bends down, and that's not going to work for us. So we can just click again, we'll get the part the right way up. Now we have a rotate piece, and this is an illustration of what orientation is the part coming to the bender, either from automation or how did you stack it, or in other words, what is angle 0 of your part. You have the opportunity to rotate that. It'll be a bit more obvious with some of the other parts we have later on. Once we've clicked OK, we're into the bender environment. So a few things on control of the view. Your mouse wheel button will zoom in and zoom out. Okay. Your left-hand mouse button will select items, so we can select anything that's in the cell here. The right-hand mouse button, if I hold it down, will allow me to pan. I'm holding the right mouse button down and I'm panning. And then if you have a center mouse button, or sometimes it's click down on your scroll wheel, click down, then we can start to rotate the view, okay, provided you have MasterbendCAM in 3D installed. The view pivots around wherever you clicked. If I click here right on this corner, you can see it pivots around that point. If I click up here on this corner, it pivots around that point. So just practice that and you can see how you can rotate your view and put the bender in the orientation that you would like. There's also view buttons like we saw when we saw the part here. We've got viewpoint from the front, the back, left, right, top, bottom, isometric. We can set everything to transparent or wireframe, or solid, which is most likely what we have, and then we can always reset the view. And we have our measuring device here, so we can still take a measurement of the part or anything that we want to know what dimensions we have. You can click on the measuring to turn that off. We also have shortcut keys. The shortcut keys we can touch on the keyboard. F for front view, B for back, or for right, L for left, I for the isometric. Then there's also U for upper view, or from the top. And then we also have D for from below. Back to isometric. It's also possible to hide elements of the view here to make things easier to see. So if we're bending parts inside, sometimes this C-frame of the machine can kind of get in our way. We can easily select it. And over on the right-hand side, we have skin visible. We can say, instead of being true, we can set it to false. And now that C-frame is no longer visible. And we can see basically the inside of the bending frame of the machine. And this is quite useful when we're doing some bends to see what's happening. If you want to bring that back, up here we have Process and Cell. We can click on the Cell tab, scroll right up and pick the slot. This is the whole machine. And here you can turn on Show Cell Objects and it'll turn everything that we had off back on. So we go back to the Process tab and we can click on the Bender Process, and we have a lot of icons up here and we'll start to explain those now. This is a new, we've already done that. We've brought in our part. We have Save. That saves the project that we're working on. It doesn't necessarily make the program to go to the machine. Open is to open existing projects that you can edit and work on. This is grayed out at the moment because we haven't made any program yet, but once we make a program, this is called PFP Export. This makes the program that goes to the panel bender that you're going to run. Now we can choose ASP brackets. So I'll click on this and we'll get a dialog box. The ASP brackets allow us to perform ASP functions. The ASP is essentially short blades that will bend parts of the bend line, not like the main blade that bends everything in the bend line. So think of it as fitted lower tooling for press brake, where I don't want to bend everything that crosses the bend line. I only want to bend certain pieces of metal that pass the bend line. In this window here, again, we can scale the window up and have a good look, and it's showing us the ASP brackets on the machine. These are these brackets here on the left and the right. And right now I've got 600mm brackets on both sides. Depending on your installation, you may have 900mm or combinations, or you may take them off. So mostly you'll have ASP brackets. It's quite normal for us to sell machines with ASP brackets, and your applications support will make sure you have the right selection there. The next step would be ASP blades. And here in this setup, I can manually add blades. We'll have an ASP part and we'll go through that separately. But here you can see I can pick a bracket, select a tool and add it. Now that tool has been added to the ASP blades. We'll cancel that for now. The next icon is the engrave tool. We can select an engraving tool, and that may be an IEU Easy, which is an engraving tool, or an IFU, which is will have rollers on it that will form a hem flat for us if we need it. Or we may have UCP, which is unload cut profile. We have sample parts that will show all of those later on. Then we have to choose AUT blades. This dialog box allows us to set up the machine with additional upper tooling. This shows the carriages for the AUT, and then we can pick an AUT tool and add it, much like we did with the ASP. There's always a grip that we can slide tooling around as well. You may want to check a box to allow different AUT tools on the same setup, depending on the parts that you're making. And we may or may not want to show the upper tool in place just to see how that tooling looks with the upper tool installed as well. The next icon is to change the standard number of tools. We'll show that in the tool composition later, but what we can do right now, most machines will have a certain number of standard segments. We can change the number of standard segments. We can remove tools physically from the machine, and that will allow larger gaps or multiple gaps, or allow us to make more space between the end tools, these are the mobile tools, and the standard tools. When we click on this, essentially we're changing the number from 49 in this machine, for instance. Let's change it to 45, and we'll see the length of the tooling makeup reduce. And there's less tools there now. Let's change that back to 49. Now we have all of our tools installed. It's possible to change or select the gauging blocks. Usually we'll leave those be because they've been installed from the factory and there's no need to change them. The upper tool clamp. This is the standard upper tool clamp that grips your part. Here we have upper tool clamp, and we can select, if you've purchased them or if they're installed, we can select different types of clamps. So we have the standard clamp, we have an upper bridge clamp, and that allows us to step over a flange and get parts closer to the bending line. Or we have a full face clamp, very useful for delicate materials or materials that may slip for some reason, where we get a lot of friction on the part. Rotator plate, this is the plate underneath. We've got a standard rotator tool. Possible you will have a customized rotator plate and that's usually application specific, and the factory would have supplied it. Centering tools, we have this feature called ASP centering that's used in combination with AUT T7. That's for press brake operations. Here's a video of that. So here with the centering tools, we would assign centering, ASP centering on the left or the right. For instance, right hand down, we'll see this now it's installed. There's the centering tool that you just saw in that video. So once we have these elements installed, it allows the software to keep them in mind for consideration for collisions, etc. Turn that off. Then we have features, shared parameters. This is something we're generally not going to touch. Your applications engineer will set some of these features for you. Then we have create a problem zip, and this is quite important. If you're having issues and you need to reach out to us, you can create a problem zip. Once you've created a problem zip, it will essentially grab all of the files that are needed, including the file you're working on here, put them in a zip file, and you can share that with our applications team. Then they will be able to help you with your part on your machine. Once the zip is made, you can add programs that you're working on, any additional files, screenshots, recordings, etc. The more detail you provide, the better. And once you say OK, it'll create that file that we can send into our applications department. Some more buttons we'll get to when we're programming. We have a long side cycle. That's for creating automatic mending programs based on the long sides first. We have short side cycle, automatic sequence with the short sides first. And then we have porting. This is useful if you have a couple of different benders in the one factory and you want to take a program that you've made and move it to another machine. We have porting that will allow you to move it from one machine to another. Import tooling is quite useful if I've taken the time to set up my machine and add ASP tools and AUT tools, and I don't want to do that for every program. I can import the tooling setup from some other program and it will automatically add all of the tooling that I need. The DB viewer is our database viewer. And again, our applications team will set up your specific materials and what you're running at your factory. So I won't be getting into too much detail on this, but there's usually the standard materials are already included. There's some stainless steels, we've got some aluminums, mild steels, zinc coated or galvanized materials. And then we have different thicknesses, and it's possible to apply different K factors and external radiuses to these parts. And then parametric. If parametric option was purchased for the software, you'll be able to perform parametric operations. So we have our four-sided part that's been imported here already. Let's look at the process, bender process, and this tree is going to build a program for us, and we'll see these nodes. This centering conveyor phase is the first node we're going to have a look at, and it's automatically being programmed, but we do have the opportunity to make changes here. We can click on this loading unit phase, so we're going to see icons up here appear depending on what node is selected. So we're going to select the loading unit phase now, and we get a new window that shows how the part was loaded into the machine. Now this varies if you have a fast bend or a BCE or a BCE smart machine. You'll see different options here. This is for panel benders, EBE, FM style machines, where parts are either brought automatically in from a punch shear or a punch laser combination machine. What we have here is, again, we have different views that we can look at, and usually we're looking from the top down when we're looking at loading the part. Possible to set the center point of the part. So if you have some peculiar geometry or different shape of the part, you may select different ways to identify where the center point of this part is. There may be some other sheet metal feature that's out here that doesn't have any bends on it that could offset the center of where the center of the bending is actually happening. You got a chance to set that correctly here if you need. You can select it with 2 lines, in which case it would say, one bend here, left click, and it's figured out where the center is based on those 2 lines. We could say 4 lines, 1, 2, 3, 4, and it's calculated the center point. Or we could say center on the bottom face, and that's that face inside the flanges here, and it's already picked the center. Or center on the bounding box, and that's the external shape of the part. We can always reset the selection back to where the machine picked it by default. It's possible to offset the center, so we may say let's change the center by 50 millimeters in one direction here, and you can see that it's moved it, okay? And we can set that back to 0. So you can always write in a hard code, move the center point of the bending where you want it. It's also possible to change the angle of the part when we're centering. With the center point selected, you can see that the manipulator is picking it here. We also have these extra dimensions that we can modify here. Sup-X. So Sup-X is will allow me to shift the part up or down relative to the gripping of the bender. So this may be, again, we've got some features, some tabs sticking out on the part that aren't necessarily part of the shape of the part that we want to bend. We can make modifications here. If I take the Sup-X, it's at 226 millimeters right now. If I change it to 300, we can see what happens. It moves the part. There's about 75 millimeters up, back to 226. If I change it down, 150, you can see it brings it down relative to the grippers. Back to 226. The Sup-Y will move where the part is picked from left to right. So the Sup-Y, it's at 327 right now. If I change it to 400, you can see that the gripper has moved left. If I change it to 200, the gripper has moved right. Then we can put it back to, I think it was 325. Sup-L is basically the spread of the suction cups outwards or inwards relative to the central line of the suction cups. So here we can set the Sup-L to a narrower position if I wanted to pick apart. If there was some features on the part that I didn't want the suction cups to touch, let's set it to 200. You can see it's narrower, or we could have set it maybe a little bit wider. You have control over it. Now, any of these, you also have the ability to hit, micro adjust them here, or you can also click into the box and roll your mouse wheel up and you'll see them change. The manipulator grip is set to the center right now because it's going to grip on the center point by default, depending on where we set the center point. But here at this point, it's possible to change the manipulator grip. We can move it 100 millimeters down and it will grip here. This is a smart way of avoiding a reposition when the part comes into the machine. Here I won't have to do a reposition, I'll have just picked it in the right spot to start with. You've got arrows where you can turn the part around relative to how it's being picked, and you can see it's applying the corrections to it as well. And then double sheet detector can be turned on and off. Air blow separation can be turned on or off. Sheet separation. Here's a clip of sheet separation in operation. And then clamp angle, we can tell the manipulator to grip it at either 0, 90 or 270 depending on what we want to do later with the part. One other feature in the centering screen is that we can set all of those parameters that you saw per rotation angle of the part. So this settings is for 0 angle rotation of the part right now, but I could have a completely different set or force different settings for 90, 180, 270. So you have total control over how the part is picked depending on whatever angle that part came into the machine. It is fully automatic. Our machine will automatically assign the gripper if the part is coming at 0, 90, 180 or 270, but maybe the automatic just doesn't suit you because of some of the features in the parts. Let's hit cancel on that because the default settings that it already picked were great for us. I am going to go back and change this manipulator clamp though. Let's go back to where our clamps were and just go back to the standard clamp tool. That's centering as far as picking it and delivering it into the machine. This is not the precision centering that we're about to do with our first bend. Next step for us is to start adding bends. We'll click the automatic bend sequence. And up here first, we're going to add a single process. So we'll add a single process. And in this screen, we get to pick the bend we want to apply to. We're going to see that we have bend number 1, 2, 3, and 4. We could select them here, or we can click on the bend. And if I click on the bend, we have options of what type of bend we would like to do. For now, we're going to do a standard bend. And then we're just going to say OK. In the standard bend dialog box, we can decide that this bend will be performed with the blade, the regular blade, our standard blade, or the ASP left-hand blade, or ASP right, or both ASP. We'll get to ASP in the next part. We can decide if we want to use AUT tools, or to include a move of the ASP blades. Because this is the first bend, we don't have a disengage, and we don't need to rotate under the upper tool, and we don't need to close our tools. Our tool setup is about to be performed with this first bend. It may be that we want to define a reposition. So remember when we picked the part and gripped it, we didn't grip it in the correct position for some reason, and we may need to define a reposition right away. So when we want to define a reposition sequence, we can click on that button and we get a new dialog box. The reposition will allow us to move the gripper relative to the part. In this case, I may want to make space for the bend. And what it will do, it will grip the part with the upper tool at the edge here, and it will move the manipulator back. And I can grab this grip right here. I can grab the red arrow and move it where I want, or I could type in a number. I could create a misalignment. Misalignment will allow me to perform a reposition that I can move the part relative to the gripper left or right. And that sequence will be done automatically. I could create space and misalignment. So in this case, we'll have a first reposition where we're going to move the part, and then we'll have a second reposition that will move the gripper relative to the part. And then finally, we may want a diagonal movement. And what this will do will move the part and the gripper in a certain diagonal motion, and that could be quite useful for dodging large holes in the centers of panels. Next, we can define the centering side. In this case, it's going to center on this long side, but it's possible to rotate the part and change the side that we do the centering on. And that's the precision centering with the gauge blocks. Finally, we have the first bend angle. The software already knows it's a 90-degree bend. It's possible to perform some other angle that we want. Maybe we only want to bend this to 60 degrees, and we could write that in here. But typically, for the moment, we're going to bend the angle that was already detected in the face. So we'll say OK. And once we say OK, we get our first bend. Up here, you'll see that we have this new standard bend. Bend number 1 on the 90-degree side of the part. So we can simulate this bend. Now we come down to the bottom of the screen. There's a few modes down here. We're going to look at some things here. So right now the simulation will be performed at maximum speed. Click this arrow, you can perform it blind. What it'll do is run through the entire simulation but not actually show you anything changing on the graphics. We can run it at different slow speeds, 2x, 4x, 8x, 16, 32x. 2x is usually suitable if you want to slow things down. Keep it on max speed for now. Now we have a play button. The play button will run through the simulation. It will run whatever is selected. If I pick the bender process up the top, it will run the entire simulation. If I select one bend, it will only simulate that one bend. So here we can start from the top and then push play, and we'll get everything including the centering and the gauging and the bending. But if I select only the bend, we run it, you see it didn't show me the loading. It only showed me the centering or the gauging of the part and the bending. If I selected one of these subparts here, just the standard bend, it should avoid the tool composition, the centering and the rotation. So we'll just see the bend. Push play, I just see the bend. Okay, let's run that one more time. Bend. When we're running the simulation, if it's a long one, we're running the whole program, we can stop it or we can pause it. And then we can also tell it to step through one at a time, or one frame at a time, if you can imagine that. And then we can increase the number of frames here and run, and you can see it now, it's moving a little more. And if I increase the number of frames a little more, and then step, 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 it's running in bigger steps. Cycle time gets calculated when we have time calculations turned on later. Any errors will pop up here. And then these are important. This is collision detection. So this is enabled right now. It's got the square around it. If I click on it, I'll disable collision detection. We're going to leave this on. Time study will give us a result at the end of running the simulation. It'll give us a time. And then piece collision check. This is going to check that the part, if it collides with itself. So we're always watching that the part is colliding with parts of the machine that it shouldn't be, but it may be possible that the piece collides with itself, and that could be turned on as well. Let's go back to the process tree, standard bend. And once we select standard bend, if I add a single process, while standard bend, this first standard bend is selected, it will add a new bend below it. So it always adds a process below the bend that we've done. So let's add another single process. We'll select the other short side, standard bend, OK. We get the same dialog box. We have some options here. Right now, we're just going to click OK. Everything's fine. We're going to use the standard blade. I don't need to do a repo. I don't need to do a new centering, but I have the option to do a centering again if I like. You can center anytime you add a standard bend. You can add a centering. Now the second bend has been done, and we can simulate that if we want. Now we can see there's a difference between this standard bend and the first standard bend. It's got some different features in it. So this first standard bend had a tool compose, a centering, and a rotation. Second bend had a disengage and a rotation before doing the bend. Let's talk about some of these elements. The very first time we make a bend, we need to set the tooling up to make the part. And here you can see the tooling has been set. The ears are here, and I have standard segments, and the spacing segments are already selected. If we select Tool Compose and come up here to this icon, Tool Compose, we'll get a dialog box for the tooling setup. So we've got lots of options here. Right now, the tooling composition is set up to include the end tools. It's possible to set it to run without the end tools. If I select without the end tools go away. They're moved to the end of the setup. One end tool is the equivalent of 4 standard segments. Okay, so you can see that swap quite clearly there. Without end tools, with end tools. You may want to leave the end tools to the side if you're running very thick material. Next is the bend composition length, or the bend length. So this bend length has been automatically selected based on the longest side of the base face. We look at select bend, it will be this bend here, and it's measured 604.4 millimeters. So that bend is what's being used to set the tooling length. You may set it to one of the other sides if you need. Even though we've told the bend length to be exact, that it's exactly 604.4 millimeters, the achieved length is what has been made up based on our tooling. Our tooling has 4 millimeter segments, so the resolution of the tool length will be in 4 millimeter increments. There'll be some difference. In other words, the tooling will always be slightly shorter than the bend length that we need. Lateral gap is a safety gap, and that's a gap that will always be between the ends of the tools and the part when it's formed around it. Offset, we can apply an offset, so we can slide the tooling to the left or to the right of the setup. If I roll my mouse wheel in here, you can see the tooling offset to the left or offset to the right. And you can put a number in here or dimension and get that offset. Spacings. In the spacing, we have a left position, number 6. So this is 1, 2, 3, 4, 5. The end tool is considered as 1, even though it's worth 4 of these. That's number 6. So the space between the tools is set at position number 6. We can change that to 5, 4, 3, 2, 1. 1, 2, 3, 4, 5, 6. The length is the dimension of this gap, and we've got a measuring tool here, and we can pick from here to here, and you can see it's 100 millimeters. We could change that gap to 50 millimeters, or let's try and make it quite large, 200, and you'll see what happens. We get an alarm that tells me the value cannot be greater than the maximum. The maximum space available at the moment is 100 millimeters. If I wanted to make this gap wider, I would have to remove tools from the upper tool setup, and you saw that earlier in the video. Let's leave it at 100 millimeters. That's the spacing for the left. You also have control separately for the spacing on the right. You can see I can change the gap here and also the length. Open multi. If you have this option installed on your machine, it's possible to create multiple opening positions. Here we can say I'll have a 20 millimeter at position 2. And I can add another position. I'll have another 20 millimeter position at position 3. And I'll add another one. That's 40 millimeters total of 60 left. And put this at position 6. So what we've done here, I've added a 20 millimeter gap, a 20 millimeter gap, and a 60 millimeter gap. This multi-gap spacing is maybe something that you'd like to see for parts that have embosses or features where we just want to step around them, and we can split the tooling in different locations with our tool change robots. Let's delete those for now. Gaps reset. Internal spacing is some amount of gap or space that we can have inside the tooling that applies just a little more precision. Maybe it's okay. We said that the bend length was 604, but the achieved is 598. Maybe I've got a part that's very sensitive on the corners and I want excellent quality at that corner. I may add 1 or 2 millimeters of an internal space where we're not going to see much difference here. We're going to have, it's going to be a nice quality part that we're going to make just by increasing that spacing. Normally we're leaving it closed. TCS final positions, we don't see them in this screen, but it's possible to locate the tool change robots or tell them to go to a certain location after they've finished doing the tool change. Move man P, this is your manipulator, and it allows us to move the manipulator to some other position while the tool change is happening. If we just close that screen, it won't apply any of the changes. So we're back here to our first bend. I'm expanding the tree. So we've gone through tool compose. Next thing is centering. Centering, I get a new icon. Click on centering. And here we have the opportunity to set or see where the centering pins are. Now this is automatically selected, but if for some reason or some shape of part you have, it doesn't let you do the centering, you've got the option to come in here and override it. So there's plenty of settings here in terms of where these centering pins are going to go. If you look, you'll see there's a round highlight that will highlight on the part where we can center. We'll see that better in some other parts later on in this tutorial. Rotate. We have rotate selected and simulated. We'll see what it does. Just does the rotation here. Run it one more time. You saw that it pulls back, rotates, and the upper tool comes to its entry position. Here we've got these new icons that I can override what's happening while we're rotating. So maybe the manipulator position, if I select it, I can say instead of pulling back so far, let's do the rotation a little closer. I clicked and dragged on the green arrow and then hit enter, and that stores that location. Now when we run the rotate, it'll happen in this position. We can also select the upper tool in position. What this is the height or the gap between the upper tool and the lower tool before the part is coming in to do the first bend. Maybe I've got some curvy material and I want to have a slightly higher opening for some reason. We can select this upper tool position. I can grab this and move the tool to some higher point. And again, if I simulate the rotate, it comes to that position and does the rotation where we asked it. And finally, if we look at the right-hand side view of the machine and select rotate again, we have control over the position of the blades. So right now, the blades are sitting just below the main tool. I could grab and just say, okay, wait there while we're doing the rotation. So you've got control over where the blades are while we do a rotate if you need as well. We're going to see these grips show up a lot in later parts. Just another function of when we're controlling the machine. These were quite visual. I selected the manipulator and I was able to grab it and move it. You're also able to, up here in the top left, you can type in a dimension and it'll move it to that position. You can see that the 450 is measured from the ends. 0 would be if it was moving all the way to the front. If we make that number lower, 400, it's closer, and 300 would be closer again. You can also select the increment. If I mouse wheel this, it's going in very small increments, but I can select it to go 10x, and it moves a little bit more with my mouse wheel, or 100x, moves more again, or 1000x, moves quite a bit. Once we've moved it where we want, we just hit enter to store that location. So with a close manipulator position, it is possible to rotate the part underneath the tool. That was using the grips. That's quite visual, very handy kind of way of moving the machine around. We also have a dialog box that brings up all of the things that we changed visually with inputs, so we can actually hard write in dimensions here that we want anything to move to. Something else we can do here with this dialog box is we can skip a pre-rotation. What that means is that the manipulator will pull back to its dimension before rotating. Our machines normally, as they approach the dimension of where the manipulator should be, will start to rotate a little early. And that, just shaves some milliseconds off the cycle time. We can skip that here. We can also skip wedge down. That's the central tool. We can force that to stay in its location. As for forcing rotation, it's possible to tell it always to move counterclockwise or clockwise. In our case, it'll just move to the nearest. So we've done tool compose, center, rotate. Now let's look at the standard bend itself. Again, we have new grips for what we want to do here. Let's look at the dialog box first in this case. So standard bend. What we have in this dialog box are all of the settings that the machine will use to make the first standard bend. We have two bend trajectories, circular or rolling. Normally we're using circular bend. That allows us to have a close air gap. Now what is air gap? Air gap is the distance of the bending blade from the tool of the machine when we're bending. Let me cancel this and we'll look at the side, and we can see when we start the bend, simulate the bend, that there's a distance from the tool or from the bend to the tip of the tool. So when we're in circular mode, you can see that the air gap at the moment is set to 7.6 millimeters. That's basically the width of the V, if you were thinking of that in press brake terms. The thicker the material, the bigger their air gap. Now there's a difference between circular and rolling mode, and you can see what's happened here. The air gap has increased. Circular was 7.6, rolling mode is bigger, because the rolling mode will start the blade bending further away from the machine. And as it moves, the tip of the tool rolls on the part and leaves no mark. So if you're running stainless steels, pre-painted material, any witness line of a mark is completely not acceptable. You can switch to rolling mode. But the problem with rolling mode will be it needs a bigger air gap. When we say OK to this, you'll see that the tool will start further out. It's further out here now. So if I had a negative bend, it could have impacted that. Back to the dialog box. So we're normally using circular mode. It gives us a tighter air gap. We have control over where the blade is while we're bending, where the manipulator is while we're bending. And we've got something interesting here, position control. Normally the upper tool, let me cancel that and show you a bigger view here. The upper tool will clamp with a force. If we enable position control, it will close to a dimension. Now this is quite good for parts that maybe have some form or feature where we just want to kiss the part while we do something to it, or we want to just come to a dimension instead of a force. Final positions is where the upper tool will rise to after it's done. Here at 3.5 millimeters is what it's going to come up to. And we'll get to XY offset later on a new part. So standard bend is done. The next standard bend, we can run that simulation too. And that's this next standard bend, we had a disengage. The disengage is how we get out of the previous bend. And in the disengage, we again have control over the upper tool, where it is, what the final position is, and it's calculating how high the upper tool should be in order to retract this part. In this case, 33.4 millimeters. It was done automatically. If we run the disengage, you can see that it moved forward a slight amount, and then the upper tool came up. That's to prevent us from catching anything on the metal. Something interesting to note on benders as far as design is that let me grab the upper tool here. You can see that the bender moves on an arc. See that it's moving away from the arrow here. I'm moving the arrow directly up and down. The upper tool is moving away from it. So keep that in mind, that there's an arc to the trajectory of this upper tool when it's in motion. So let's continue to add our bends. We'll select the last bend that we did and add a bend below it. Now we're going to do alongside, standard bend, okay, okay, and add another bend, alongside, standard bend, okay, okay. Let's come back up to an isometric view. Select the process from the top, bender process, and run the simulation. That ran the entire simulation from the start to the end. Remember that if we picked an element or the bend and hit play here, it will only run that part of the simulation. We have a new button down here that's highlighted now, and this will allow us to run override or play through. And what it'll do is it'll start from the item I have selected and continue on through the rest of the program. So let's hit play through from this second to last bend. You can see it'll do that bend and it'll actually carry on and finish the next side. So we've bent our part. The next thing is we need to get it off the machine. So we'll come down here to the unloading and pick a belt unloading sequence. Here we have an opportunity to include a disengage, which is quite normal. This is what we're normally going to have here. Or move ASP blades if they were in the way. We've got an option to include that. Turning this on or off, or move ASP on and off, essentially adds the node to the bending dialog and allows you the option to make some changes. You can change the angle that the part is rotated at. So maybe you want a part unloading at a certain angle every time. Maybe it's always coming this way. You can change that angle here. So now that the unloading is done, again, we can simulate just the unloading. You can see that I added a 90 degree. It turned it before unloading the part. And that rotate is here. If I didn't have that rotation change, there wouldn't be a rotate here. We select the belt phase. We can go to the dialog box and we have control over some things here. We can change the manipulator position when it unloaded. Maybe the part has a big hole or an opening or a lot of flanges on one side that makes it unbalanced, and maybe your part is kind of turning or skidding around as it's being unloaded. You can change the location of where it's placed on the belt to make that a bit better if you need. You can type in a dimension here, or you can always come up here and grab the manipulator grip and just physically or visually change where you want it to unload. So the belt conveyor will pop up in between this slot here. We'll come back to the dialog box. The clamp open is all the way. This is how far open this manipulator goes. So you can have it all the way open, half open, just a small gap, 5 millimeters, or open with a timer. Then the buffering, we're going to see some buffering here. So in the buffering, we can have TUT buffering, or we can have line unload, which means just keep on going. It sends it on to another conveyor. The holes existing makes the machine interact differently with sensors that are going to detect the part as they come. So it basically runs on a timer instead of waiting to detect the part. But with that done, we come to bender process. Let's save our part. We can give it a name. We can go in a folder. I'm going to overwrite my last one. And then once the program is saved, we can make a PFP export. And this will be the actual program that needs to go to the machine. So we click PFP export. it asks for a location for that program to be saved. It could be a network drive. Maybe you've got direct access to the hard drive of the bender. Usually a network drive is the best place for that to go. And now you can see it starts to do full collision check and testing. Make sure that you've got a valid program, and then it will process the file. And we're done. You've made your first program. So you've made your first program in a somewhat manual method. We've gone through a lot of detail about the nodes and how to manually override a lot of what the machine is doing. The next step for us now is to start automatically programming. We've got two modes of that: fast programming and then full automatic programming. So let's get started with those. Okay, let's bring in a new part. We've got an 8-sided part we're going to start programming with. So we'll come to NC Express, File, New Part, and we're going to grab our next solid model, and we're going to do this simple 8 bends, grab and drag into the main workspace, and we'll move that out of the way. So again, select the part, convert it to sheet metal, change the top side if you need. We're going to leave the top side on the outside here, and we're going to unfold the part. Now we'll hit File, we have our new flat pattern. So from here, we'll File, Export, and save the PFP file. Then we can come back to MasterbendCAM. New, you could save your last file if you want. We'll pick the 8 bends part, make sure we have the right bender. So I've got my EBE 2720, simple 8 bends, and say OK. So we've seen this screen before. We can pick our base face, it's automatically selected, so we're just going to say OK. We can change the rotation of the part as it was loaded or sent into the machine. We're just going to say OK. And already centering has been taken care of for us, and we don't need to see that again. We have our part as being gripped by the manipulator, and it's ready to start bending. So we'll come to automatic bend sequence, and we have a second option here. Previously we did add single process. Now we're going to do fast programming. Let's click the fast programming button, and we can zoom this in a little bit here. What this allows us to do is to pick a sequence of bends that we like and automatically apply those bends to the part. So the last time we picked one bend at a time and applied the process. Here we're going to click a bend and a bend, and then I can do the same on the short side, long side, and you can see I've selected the sequence that I want. Now you can hit delete on any highlighted bend and we'll delete those bends. Okay, so let's just show you something else that you can do. If you hold down the Alt button and then select a bend on a side, it'll select all of the bends on that side. So I can select all of these bends by holding Alt and clicking 1, 2, 3, 4, and I kind of get the sequence that I want. Say OK. And you can see very quickly it has applied all of the bends that we wanted. I do still need to add an unloading sequence here, so we'll add a belt unloading sequence. And that's a full program ready to go. So come up to Bender Process, push play. What I like to do sometimes is just hit the left-hand view and scroll right in. We have a program made. You can save that program now. Okay, let's come back to an isometric view. What we're going to do next is show full automatic programming. So what I'm going to do is delete all of the bends that we made. We can come to the unloading belt sequence and hit the X, and it will delete the unloading belt. And then I can select a bend, start from the bottom and work your way up, and just remove each of these processes by clicking on the X, and it deletes the bends all the way up until all the bends are gone. Now we're back to automatic bend sequence again. But come to Bender Process. When you're up at Bender Process and there are no bends on the part, we can have these new buttons here, long side cycle or short side cycle. Now for a part like this, short side cycle is most likely what we're going to do. So let's do short side cycle first. Simply click on the button and it'll automatically make all of the bends for this part. You can see the bends appearing here. Short sides first, long sides last, and we can run the simulation. What's nice about auto programming is it also includes the unloading with the belt sequence. So we can run the program. And the unloading is done too. That's great. If we wanted to do long sides first, and I'll show you an example of a part that may need long sides first. So we'll use the option called CLL, which will allow us to split the tooling midway through a process. Let's delete all those bends. Let's get rid of the unloading sequence again. And start from the bottom and delete all the bends. Select Bender Process at the top. Now pick Long Side Cycle and run it. So watch what it does here when we simulate. It sets the tool width to the length of the short side. The tooling is fully compacted, so the tool is tight and we have all of the tooling together. And then we perform the split and do the short side. So you can imagine this is good for parts that have maybe miters or where the differing lengths on the long side, and I need to get them all done first before coming into the short side. So again, a little closer look at that. Tooling is all together, push tight. And then when we come to do the short sides, TCS robots will come and do the splits. There's the split. And then we do a short side, tools compact, short sides, tools compact to extract. And that's automatic programming in a nutshell. Now let's do some more complicated parts. So that's a fairly simple part. We've done long sides first, short sides last, or normally with a piece like this, we'll see short sides first, long sides last. And with fast programming or automatic programming, you can now very quickly make simple programs quite rapidly. Next part we're going to work on has some more complicated bending. So now we're going to see ASP blades, and weld tabs in an enclosure are a great example for that, where we've got bends that aren't on the same bend line but very close. If you're ever at a press break and you see that the operator has split their lower tooling for some reason, that's usually an indicator to me that we need ASP tooling. So whenever I'm looking at fitted lower is the term on a press break, then we start to look at ASP. So let's start with the ASP tools. So again, we're going to go back to NC Express and import our part. Let's grab our next piece here, and it's going to be this ASP weld flange box. So we'll drag and drop that into the screen, move that folder out of the way, and you can kind of see the panel that we have here. We've got these weld flanges that are not on the same bend line. So we'll take our part, convert it to sheet metal, unfold, file, we get rid of our previous geometry, and you can see what's happening here. These bend lines are just off of the main bend line here. So we're going to need ASP tooling to do this bending. If I didn't have ASP blades, this when I'm bending this bend line here would also bend these but directly in line, and then those flanges won't come in behind the face when we're ready to form up the box and finish it. So again, we'll do File, Export the PFP file, ASP weld flange box, save it, and back to MasterbendCAM. Let's come up here and select Bender Process, gives me my icons, and I'm going to do a new part. Again, you can save your old one if you like. And we're going to pick our machine and ASP weld flange box. Here it is. So again, it's asking for the base face. This is already correct. Let's just say okay. And the orientation coming into the bender, let's just say okay. Now what's nice here is the measuring tool, and we're going to figure out the length of the ASP tooling that we need to install. So we're going to, first time we're going to bend this part, we're only going to use one piece of ASP tooling. Then I'm going to show you a faster way afterwards. So we'll take our measuring device and measure the length of this flange here, and I can see it's about 500 millimeters. So if I use a 500 millimeter piece of tooling, it'll be enough to bend this flange, bend this long flange, and bend this other flange all independently. So let's use a piece of 500 millimeter ASP tooling. What we're going to do, we're going to select in our bender process ASP blades. We'll pick ASP blades, and I'm going to put some ASP tooling in the lower portion here. So we'll select the carriage first, and then we're going to use ASP S1. In this case, we're going to add it. Once that's added, I've got my 500 millimeters of ASP tooling here. We just say OK, and now it's installed in the machine. ASP tooling is always referenced off an edge of the carriage here, so it's flush. Okay, you can move this around. We can go back into the ASP tooling here. And of course, I can grab this and I can move it some other location. And I've got a blade position here or dimension, but you can set that right back to 0 if we need, and say OK. So to start to bend the part, we'll pick our automatic bend sequence and add a single process. So we'll pick this short side first, standard bend, OK, with the standard blade, OK. Next step, add another bend, but what we're going to do is we're going to bend this flange here because it's further away. And we're going to pick a standard bend, OK, but we're going to tell it to use ASP left. It's fine. Now, let's run the simulation. We'll rotate our view around. We'll run the simulation here and we'll see that we're using standard blade to do the first bend. And then in comes the ASP carriage to do this one. Let's add the other two short bends. So we'll go back to add a single process. This flange here, standard bend, OK, with the ASP left, OK. And add one more. This flange, standard bend, OK, with the ASP left as well, OK. Now, something interesting has happened. ASP flanges and bends are referenced off one side of the carriage. And we're going to have a problem here. This tool is in the wrong location. So watch what happens when we run the simulation. We're going to get our first crash. So in comes standard bend. Comes the ASP. This is OK, and we're going to get a crash here. Boom. So what we have now is it's highlighting where the tool is hitting the part. In order for this to show up, we needed to have this piece collision. So this is where our machine crashes with the piece, okay? Not the piece crashing with our machine. So it's one or the other. And what's useful now is let's turn off the C-frame. You saw how to do that earlier on in the video. So you hit escape, and we're going to select the C-frame and turn that off with false. And now I can see through everything. So what we need to do is to adjust the position of this carriage when it's doing this last bend. And over here we have a new ASP positioning dialog box. Now a couple of things. We've got the ability to change where the upper tool in position is, the manipulator, and where the C-frame is when it's doing the bending. But we want this dialog box here for ASP positioning. We have this graphical box here. And now what we can see is where the ASP blade is. It's referencing off the right-hand side of this flange. And what we wanted to do is to reference off the left-hand side. So with the ASP tool selected, we can hit alignment of the bracket and change it to the left-hand side. So you could do center, right, left, and sometimes you want to pick a different position here. So from the left is good. We'll say OK. Now it's in the right location, and we can select that bend and just simulate that bend. Perfect. So we've put a little bit of effort into that side. Now what we can do is phase copy. Let's copy some of the flanges over to the other side. First off, let's add our standard bend to this side here. Now we can come up here and do phases copy. This gives us a new dialog box and allows us to pick some bends and apply them to other sides. So we're going to pick the ASP flange here that we did, and then we're going to hit Control and select the other bends that we want. There's one ASP, two ASP, so we've got three ASP flanges here, and we're going to add them to this other side. So we're going to select the ASP flanges that we want just by highlighting them and apply it. The bends have been applied, and we can just say OK, and we'll have our new flanges here. Let's go to the top of the bender process and run the simulation. Under bend, ASP carriage, good side, side that we corrected, then a rotate, standard bend, and then a repeat. The ASP is all good. So that's a nice way to kind of copy paste flanges that you've put a little bit of effort into to another side, so you're not having to redo all of that work over again. So we've got just the long sides left to do. So we'll come over here and select the last bend in the list, and we can do fast programming here. And with the standard blade selected, we can actually Alt click on a side and wrap it up. So Alt click on a side, and it's going to do all four bends that are left. And just say OK. And the last thing left for us to do is to add an unloading phase. So we'll select the unloading node here on the right, and then come up and add belt unloading. And if you wanted to change the angle that this part is unloading at, that's okay. We'll just say okay. And we have an unloading sequence. So this is ready to go. Hit I to get an isometric view again. Just reset our view. Let's have a look here. Come to the top of the tree, bender process, push play. So this is fine. We have one piece of ASP tooling doing all of the work here, but we have two carriages, so we should really take advantage of that. And if we have a standard 500mm length of tooling, we may also have a kit or a segmented set of ASP tooling, so we can put that to work as well. Let's see what we can do here by running both ASP carriages at the same time. Let this finish up and unload. Okay. You can save that program and give it a name if you want, but really what I'm going to do next is delete most of the bends here. And I'm going to delete the two short bends that were done by the ASP carriage. So all I'm left with is the first standard bend and the first bend with the left ASP carriage making this long bend here. Let's come back up to our bender process, go to our ASP blades, and let's add a length of tooling to the right hand side. So I'm going to add a 250mm length and add it to the right hand side of this tooling, or this right hand ASP, and say OK. So what I have now is I've got ASP on both carriages. Next, what I'm going to do after this bend, this first ASP bend is done, I'm going to add a single process, and we're going to select collinear bends. So all the bends that are on the same line, and that's these two here, are on exactly the same line. So if I select all collinear bends and pick one of these, it'll pick both automatically for me. Then we can hit standard bend, OK, but use both ASP. So we could have done left or right, but now I'm going to use both ASP and say OK. And what it's done, if we simulate this bend now that's selected, it'll come along, both carriages come in and both bend simultaneously. You can see that this is a little faster. Let's manually add some of the other flanges here. So here, this flange with a standard bend, okay, okay. Let's add this flange, standard bend with the left ASP. And then we'll add, again, with collinear bends selected, the ASP flanges, standard bend, okay, but with both ASP. And then let's throw fast programming in here. And again, Alt, select, gives me all of the bends on the side. Okay. We already have our unloading. So let's watch this process and see if we can make any more improvements. So the ASP carriage is coming in all the way from one side. Then they both come together, that's fine. But then they both go back to their home locations. And then they have to come all the way back in again to do the second side. So there's something we can do, it's called put in an ASP move or modify the move locations. And that'll help us maybe speed this program up a small amount. What we're looking for, very first bend was a standard bend. You can select it and just simulate the one bend. And then the next bend is the ASP coming in from the left to do the center. That's fine. This is bend 3 and bend 4 together. That's fine. What we're looking at here is the next standard bend. If we run this one, the ASP's move and this ASP move node. We'll select this ASP move node. And what's nice here is you have grips. Okay, so we can select, we can visually drag, I can use the ASP left and drag it to hang out somewhere here and hit enter. And I can pick the other ASP carriage and drag it and come to some position just to hang out here closer. Now what happens, let's come to a couple of bends earlier and use the play through button down here, run onwards, and we'll see what happens. So after we've done the two ASP, they go to this waiting position here and just hang out. And then they're in a bit of a closer position. So this one's going to come all the way in. Now, see that move? Let's correct that one as well. So that was this ASP bend. So this is the ASP positioning of this bend, moved this carriage all the way to the left. So again, we can come up to the ASP positioning window and we can look at this position of this bracket while this bend is being performed and change that location. So if we change it to like 600 millimeters, it brings it closer. There's always a grip. I can grab it and drag it. There's good. Just say okay. And now it's going to hang out here while this bend is being done. So let's select this bend and run through. You can see it's in this nice location, ready to go for both bends. That's a nice, efficient bending sequence. That's the ASP part. The next part we're going to work on will have a big radius on it. Let's get to the big radius bend. We'll take the next part into NC Express. We'll go to NC Express and grab the folder here. And we're going to do the big radius part. Let's click and drag and drop it into our work area in NCX. Now, the thing with big radius bends is they always need some amount of a straight. Okay, so that's required. And it needs to be at least about 4 material thicknesses long. So there has to be some straight there. This bend cannot start right on the radius. There needs to be a piece here. Let's select the part, unfold it, file, and we have our part with the big radius. Again, if I select this bend line, bend info, there's the radius, a 1-inch internal radius. Okay, so again, file, export the part, save it. I'm not going to overwrite mine, and then go to MasterbendCAM. We'll come up to Bender Process. You can save this ASP box if you need. And then we can go to New. I'm going to pick the bender, of course, same bender again. And we're going to go to the big radius part and import the file. It's asking us a lot of the same questions again. Where's the base face? What's the orientation? Let's turn this one around so I'm not rotating it again. Now we'll see the power of working with 3D models. When we have 3D models and we're unfolding them, we're applying the right radius. You can see that the bend radius is very large here. This green area is normally the bend radius. We're going to apply an automatic bend sequence at a single process. And if I select this bend, you can see that it knows not to do a standard bend. It's saying this is a big radius bend. So that's been detected for us already. So we'll say OK and OK. And we'll look down the right-hand side of this machine. And if we run the simulation, we'll notice that it doesn't simulate every bump. Okay, so it's going to bump, bump, bump and make this part. But let's look at some of the parameters here. We select big radius bend on the tree on the right. We can open up the dialog box for big radius bend. A couple of things we can do here. We can tell it to bend with the upper tool. And what that'll do is it'll tell the lower blade to come to a position somewhere above the bend line, and the upper tool will push down on the material to make the bends. Okay, or in this case, we're bending with the blade, so the part will be moved along slightly, gripped, and the blade will just nudge it up each time. Something that we have here is this is the count of the number of hits. So you can have a very high resolution bend or a more rough bend with less steps if you want it to just be faster, and getting an approximation of that radius is important. Some things that will fine tune and adjust the finished radius of the part when you're actually at the machine and making the parts will be air gap. So you'll find your technician, when he's training you at the machine, might be making slight adjustments to the air gap to minutely adjust the actual inside radius of the part. And that's a big radius. So next one for us after the big radius bend is going to be a last bend negative. So you may have parts that have bends up on all of the sides except one side. One side may have a bend down. How do we get that out of the machine? So let's take a look at that. Back to NC Express again, and let's look at our folder with our parts. So we have the LBN, or last bend negative part. Click and drag that in. And let's take a look at this part. So here I've got 3 sides up, 1 side down. So we have 1 last bend negative. Let's see how we process that and get that out of the machine. So again, we'll convert it to sheet metal, unfold it. Something nice in our software is we do color code our bends. So green are up bends and red is a down bend. So that's something where very quickly, visually, I can look at a flat pattern and tell what's going on. We'll file. Quick look at the bends. One of these bends is up, so we'll look at the bend info. You can see that it's 90 degrees. This is the down bend. If I right click, look at the bend info, it's negative 90 degrees. Again, file, export as a PFP file. Come back to MasterbendCAM, select your bender process, do a new part. Pick the machine, pick LBN, and OK. Let's say OK. OK. So we'll come to the automatic bend sequence and we'll do fast programming for this. And we'll select a short side, then a short side, and then a long side positive. And then last bend is going to be down. So there's that negative bend. Let's just say OK to that. We'll run the simulation up to this point. We have no unloading at the moment, so I just want you to see what we come up against when we have a negative bend. The bender process, run the simulation. Let's look from the side. We can see here we have an up, one short side, the other short side, long side, and then our down bend here. Now, normally we would pull this part back to unload it, but we can't because there's a bend down. So we have this LBN function, last bend negative, if it's equipped on your machine. Essentially, it's this green bar that's going to push the part off, and the table to pick it up will move in closer to the blade of the machine to collect the part. To perform LBN unloading, I will select unloading here, and now we have this add LBN sequence. So we'll pick that and just say OK. And we can simulate the LBN. You can see what happens. The tooling disengages, the manipulator opens up, and this green bar pushes the part off onto the table where the flange down is sticking off of the side. And that works great for our systems with tip-up tables, and as well as free roll conveyors. So that's run the last bend negative one more time. You can see it gets pushed off the side. Now, there's some features in here. In LBN phase, I've got a dialog box, and we've got some options. This unloading mode, this is interesting. Depending on the shape of your part, it may or may not unload very easily. And what's possible is we can go to like mode 1, and it allows the bending blade to be put into a position while we're unloading. So let's look down the left-hand side or the right-hand side of the machine and run this simulation, and you'll see what happens to the blade. The blade comes to a location that essentially locks in or guides that flange. It stops the part from spinning around or shifting on us. So it acts like a channel that last flange needs to drive through before it's being unloaded. It's quite useful. Other things we have control over here is the speed of the unload, the opening of the manipulator we can control, and if buffering is turned on or off, and we've seen buffering earlier on. Belt existence is an interesting one. Let's take a look at that. If I go back to my isometric view and just go to the last bend, that was negative. So say I had a part that was very long in this direction, okay, and the last flange was down here. This pusher is pushing up at the top end of the part. Well, this is causing me an issue because the part's very long and it may have a hard time guiding it out. If I use LBN phase and go to my options and say the belt is in existence, what happens is while it's pushing the part with the pusher here, the belt will also lift up and help get the part out of the machine. So they can both run at the same time. So that's last bend negative. We've covered most of the basics of your everyday machining now. Now we're going to start getting into some more complicated flanges. And the first one's going to be a hem bend or a seam or a safe hand. So let's have a look at that part. Again, we're going to come to NC Express. We're going to go to our folder that has our parts, bring that in here, and we're going to look at a hem. We've got a one hem part, drag it in. When we're drawing hems, it's important to have some gap here. If there's no gap, we're going to have a problem. So let's look at Autodesk Inventor, for instance, where I drew this part. So you can see it's been modeled with a gap. We look at the hem function in Inventor. I've got a gap, about a 10th gap, it's enough. So as long as there's a gap there, if that has a zero gap, we would have a hard time unfolding it or interpolating it. So there must be something there. Go back to NC Express. And again, convert to sheet metal, unfold, file. And we have our bend line down here. And let's look at the bend info. And again, we can see it's a 180-degree bend, and that's important. With a very tight inside radius. The gap was 10 thou, so the radius is 5 thou. Okay, we're going to file, export as our PFP, again as usual, and come back into MasterbendCAM, Bender Process, New Part. Again, pick my machine, and pick my hem. And we're going to get the same old questions again. Say OK, OK. So we'll do a standard bend process. We'll come to automatic bend sequence and add a process. And we'll select that hem bend. And again, because it has a 180-degree angle, we get some different types of bends made available to us. Now, sometimes when we're hemming, we may not want to finish the hem completely in one shot. We may only want to partially bend it and then come back to it later. So here, I could do a standard bend. I could do a standard overbend. I could just do a simple standard bend and then smash it. Rarely ever use that one. This one is most popular for a straight hand safe where we do a standard bend, overbend, smash bend. So it's 1, 2, 3 processes all in one. Well, let's pick this one. And what happens now is I have two bend angles that are involved. The first bend angle is 110 degrees, second bend angle is 140 degrees. Let's take a look at the simulation and we'll see where those angles come into play. So we're going to take a look at the right hand side, and our bend is done, it's smashed over, and we're going to slow this down to 2 speed just so we can see more clearly what's happening. And we're going to simulate the bend. So this is selected and we're going to push play. So the part will be loaded into the machine. Here comes the pusher. I'm going to come up for centering. Lower blade is coming into position. So we're going to see this 2-step bending happening. So the first bend to 110. There, see, that's about as tight as we want to get. We feed it forward a little bit, and then we'll take it down to the 140. So you can see the 2 steps there allows me to get a sharper angle than I could have in one shot. And then once that's done, it moves out, moves in, and crushes it. That's fully automatic cycle. And again, over on the right hand side of our tree, we have access to our tool compose, our centering, our rotate. We have our standard bend that we've already seen. Let's look at overbend. Again, with overbend, we get something that we get some more things that we can change. Let's look at the dialog box. Upper tool initial positions, the delta. That's the difference. It moved it forward, so it bent it at the normal position and then moved it forward, in this case 2 millimeters, before bending over again. And then the smash bend. We look at the smash bend. This will tell us the upper tool initial position, so it starts at 3.5 millimeters. The manipulator disengage offset, that's the distance it's pulling back before coming out. Then we have the upper tool start position. So the upper tool must come up to 18, and then the manipulator has come back 40 millimeters from where it was. So that's about to this position. If we look at the measuring tool, we could measure kind of where it was, where it will be. There you go, about 40 millimeters. It did the smashing about here. And then it's this is interesting, the upper tool stop position. So this is coming to a tonnage. It's actually going to crush this quite strongly, which is, you know, good for a closed hem. But if you want to have an open hem, say that 10 thou gap was 25 thou and it needed to be 25 thou, then what we could do is turn off force control and tell it to come to a specific position. And then you've got total control over the upper tool and how tightly it closes that hem. Okay, so that's a hem bend done. The next will be a take on a hem bend. It's called a standing seam. And instead of using the upper tool to do the crushing, we're going to use the blade to come in and do what we call a blade smash. So standing seams are very popular in the HVAC industry. We see them everywhere there. Let's take a look at this part and get cracking. So again, we have NC Express. Take our folder with our parts. And we're looking for the standing seam and bring that in. Okay, standing seam looks like this. So what we have a negative bend, and then we have the hem. You can see the problem here. If I want to squash this down, I can't use the upper foot because it's going to crush this flange, and that's really going to be a problem. So let's take a look at how we bend that. We'll take our part, convert it to sheet metal, and unfold it as usual. Again, we have our negative in red and our positive in green. Let's go to File, Export, save the PFP file. Then into MasterbendCAM. Take our bender process, do a new part. We're going to select our machine and select our standing seam part. And here it is. And the same usual questions of orientation and loading. And all of that gets taken care of. We'll come to our automatic bend sequence, and let's put the first bend on, and we'll do this negative bend here with a standard bend. Okay. Let's look at our simulation down the right hand side and run it, and we can see our first negative bend. Let's change the speed back up to max speed. There's the first negative bend. Now the next step for us is to overbend this one as much as we can, and then we're going to come in with the upper blade and squash it. So if you see this video here, this is the process we're going for. Okay, so if we treated this just like a hem, we would add a single process, grab this one and do standard bend, overbend, smash bend. We're going to see what's wrong with that, okay, and why this is going to be a problem. So it's very similar to a hem. Let's run the simulation. So after the negative is done, standard bend, overbend, smash bend, and we have a collision. And the collision is it's crashing. If I turn transparent on, this is where transparent can be useful. I can see this flange here, okay, and it's colliding with this. So that's a problem for us. So we're going to delete that bend. We hit escape and get out of that. Delete that bend. We're going to add a different bend. We're going to add a single process, but we're only going to do the standard bend and the overbend. That's enough. And then we're going to add a separate process to flatten it. So we'll say okay, standard bend, overbend only, and we'll run this. You can see it does the standard bend, overbend, and it stops right there. Now we're going to learn how to free bend. When we're free bending, we're going to add a single process to the bend that isn't finished. You can see it's still showing up here, and at any time you can also come and view isometric and swing around and pick the bend you want to work on. So we're still working on this bend, it's not finished yet. And we're going to select it and we're going to add a free bend. We'll say okay and okay. What a free bend does is it gives us a placeholder to add operations by ourselves. So we have a free bend, we expand this tree and we start with our free bend here. And in this free bend, we're going to add all of the movements that we need to add to finish this part. So first things first, what do we need to do? We need to move the part to the right or forward here to clear the upper tool. And we're going to raise the upper tool up. We're going to bring the part back, and then we're going to bring the blade in, and the blade is going to squash this closed for us. So first things first, we're going to add a manipulator move. We select it, and then once we have a move man P, we select moving the man P. So there's a two-step operation. So you add a move man P, and then you move the man P. So I've got a grip, and I can drag and move that so that it's clear and hit enter. Next step is we need to raise the upper tool out of the way. So here we have add upper tool move. This adds move upper tool as a command. Within that, I can do things. Within this upper tool move, I can also move to the manipulator, but I'm going to raise the upper tool opening. That's all I need to do here. So I'm going to raise this up and drag it up out of the way, because the upper blade has to come in and do some work. So the fact that this is on an arc and makes this gap like we explained earlier is an advantage for us. Now we'll hit enter. Then we need to drag the part back over the lower tool. So here we'll do another add a man P move, man P position, and drag it back. Let's go about there. And again, your applications trainer will go through all of this as like, where's a good position to have this when I want to do these movements and so on. The gauge of the material is important. The tensile strength of the material is important. And that's part of our applications training on site. Next step is to add a movement or a linear move. We're going to add a linear move to the C frame. Okay, so I've got control now over the C frame. So what I can do is I can take this down and move it over a little bit and just get it kind of close. We don't need to be perfect right now. So just right in kind of where we want it and hit enter. Next step is that grip was on the lower tool. We want to change the grip to control the upper tool. So we're going to add another linear move, and I'm going to use this dialog box, modify the linear move, and that allows me to select the blade. And I'm going to do my bending with my upper blade and say okay. And once the upper blade is selected, I can come back and use the C-frame movement here. And now I can drag this kind of close. We're kind of going to come and touch, roughly here. That's good enough, and hit enter. The next step is to close the bend. And what we want to do is modify the angle of this flange. So we're going to add another linear move, and then we're going to come to this modify linear move, and here we get to change the angle. See, the bend angle is here. Right now it's at 140 degrees. It needs to come to 180, and that'll be it closed. So we say 180, okay, and you can see it's modified the angle of the part. Next step is to grab the C-frame again and take it to a touch position that kind of follows that arc. And again, your applications trainer will tell you where's the best place to put all of this. But this is close enough for now. So that's it crushed. The next step is to get this upper tool out of the way so that we can move on with bending the rest of the part if we have any more flanges. And the easy way to do that is just add another linear move, grab the C-frame, and just drag it up out of the way, and back, and enter. And that's a free bend made. We can come and select the free bend and push play. We can see all that it's doing. It moved forward, it moved the upper tool, it pulled back. Here comes my upper blade. It's going to come to position and it's going to squash it. Simple. Okay, so we're starting to get some complicated bends done now. We've done a hem, we've done a standing seam. The next interesting part to do is going to be a double thickness bend. So this is when we've got material that's hemmed right over and we're going to bend both thicknesses of the material at the same time. It's quite an interesting process. It's nice to add some strong stiffness to panels made from light gauge material. So let's get into that one. Okay, back to the usual. NC Express, grab our folder. And we're looking for the double thickness next. Click and drag and bring it into the workspace. So you can see what this looks like. There's a deep hem that's getting bent. So let's start this one. So a double thickness bend, again, like a hem, requires a gap. The gap should be as tight as possible and the radii should match. So this radius of this outside part should be twice the inside plus the gap, which is, in this case, I've only got a 1/1000 gap here. It's quite tight. We'll take our part, unfold it, and you can see here we've got what it ends up being a down bend, even though all the bends here are being positive. But we'll have a look at our flat pattern. And again, file, export the bend or the PFP file. We'll do that, and then we'll take it into NCX or into MasterbendCAM. So MasterbendCAM, we'll go to Bender Process, New, Double Thickness, select my machine, OK. OK and OK. So very simple, automatic bend sequence, add a single process. And what we're going to do first is the hem. So the hem gets done first, standard bend, overbend, smash bend. We'll select that process. OK. Let's take a look down the line of the machine and run our simulation. Standard bend, overbend, smash bend. Now what needs to happen is that these bend lines need to be kind of within each other, that the center of this radius is inside the green portion of this radius. So what we'll do next is we'll add a standard single process, and we can take a look isometrically at this part and zoom in. And what's going to be selected here is double thickness, and that will let the software know that we need to select both bends. So if I just picked one, but it did pick them both, and we're going to do a standard bend with those two bends at the same time, double thickness. I'm going to say OK. All of this is the same as we've seen before. I'm going to say OK. And we'll zoom back out. We have a flange. Let's run the simulation. And you can see that the position of the upper blade was correct. Okay. Yeah, there's a little motion in here. That's why double thickness bends are a bit peculiar. But the main thing is that the machine knew to increase the air gap when it's making this thicker part. It also knows to increase the tonnage. And you also have the opportunity to bend with the upper tool coming to a position rather than to a tonnage as well. So you've got a lot of control over this. So let's run the full simulation here. So from the top, we have our overbend, our smash bend, and our double thickness bend. Very simple. So that's a couple of complicated bends done now. We've got some hems, standing seam, double thickness. Next on the list is what we call a integrated stiffener or tubular bend. We're going to see a function in the machine that's available called engraving, where we can actually score a bend line with a wheel And what that does is weakens that bend and allows us to do some pretty interesting functions. So let's get on to the tubular bend. As always, back to MasterBend or NC Express, and we're bringing in tubular bend. So what we have here is essentially a formed in stiffener that maybe we're going to take to spot welding, and this will make a very rigid panel. So as usual, we'll unfold. You may have seen there I skipped the convert to sheet metal. If we just click unfold, it'll do the convert to sheet metal automatically for us. So with that done, we'll go to File, see our new flat pattern, File, Export, save the PFP file, back to MasterBendCAM, select the bender process, New. Pick our machine, and we're picking our tubular bend part, and here it is. Now we've got what we call a hidden bend that's going to be quite tight. I'm going to show you a new process here for bending. It's called XY bending. It's very useful. We have two opportunities to see XY bending going on. So let's form everything up, and we'll see the problems, and then we'll correct it and make a good part. So we'll do fast programming. I'm going to hit Alt and select all the bends and just let it do its thing. We're going to see where we're going to have crashes and so on. So we'll select the bender process, look down the line of the machine, and push play. So first we'll have a negative bend, and this positive will have a crash. So what's happening here, the tool is trying to come to this location, but there's a piece of metal in the way. It's obviously this first flange is in the way. So that needs to be fixed. Let's turn off collision detection for a moment. And as I click play, it'll run through it anyway, and then push the bend up until we don't get a collision. There, it's finished. Next step are these other two bends to make the tube. 1, 2, and we have a crash as well. So what we want to do is two things. We want to score this bend so that it's weak. We do that, we get a part like this video here. And in this case, I would have been able to do just 2 straight 90-degree bends, but I want to go through free bending again one more time. So let's have a look at that. So I'm going to delete these bends. We're going to keep this one for the moment. This is the problem one. And what we're going to do is what we call XY bending. So what we need is we need a measurement. And the dimension is going to be, well, from where it would have touched, which is here, to where I want it to touch. I'm going to get it to nudge this part up from here 45 degrees and then finish the bend with the main blade. So I'm going to come here, this dimension, 12.7 millimeters in this case. So what can happen next? We'll take this bend, standard bend, and come to this dialog box, and we're going to turn on XY bend, and we're going to set the offset to -12.7. And when we run that, you'll see what happens here. I didn't want it to finish all the way, so we'll come back to the standard bend. I'm going to change the angle to 60 degrees. Now watch what happens. That offset was too much. Let's take a look at that number again and make it -10. It's a little better. Run the standard bend. Too tight. So again, sometimes there's a bit of a estimation going on. Let's go -12. Okay, that's fine. So at the machine, we'll fine tune that. But we want to get close, at least get the operations in. And what the XY bending did was it told the machine to do the bending at an offset. We're moving the bending blade, just do what it's doing, but at a different location. Now, the other thing we could have done with that XY bending is grab the C-frame right here and just move it where we want it. So we want to start the bending just here and hit enter. So this is actually more precise than what I was doing earlier with putting numbers in there. So we'll push play here. That's perfect. Let's slow that down. That's what we want. Now, once that portion of the bend is done, I can add, come back to my standard bend, and I can add a single process. Let's look at the isometric view here a little bit. Grab this bend again, standard bend, and just finish it like a standard bend. So here's the 90 degree, and it's done. So what we'll do now is let's look at all of the bends together in full simulation. Change it back to max speed. The negative, the offset bend, and the standard finished bend. That's it, that's done. Next step, we want to engrave this bend and then bend it. So we need a tool to do the engraving. We'll come to Bender Process, and up here we have Engrave Tool. We'll select that, and we'll mount in the ASP carriage here the IEU Easy, or Engraving Unit Easy. And what that is, you can see it here. It's a set of wheels. One of them has a chisel point on it, and it'll engrave the bend line for us. So we'll say OK. There it is installed. Come down to the last standard bend. We're going to add a process after that. So we'll select Add a Single Process, and isometric view is nice just to see, make sure which bend we're picking. This bend here needs an engrave. So this bend is selected, and I have the option to engrave it. OK. And it's going to use it with the IEU, which is what we have installed. And that's that done. So let's zoom out and take a look at the process with the C-frame hidden. So it's using the ASP carriage to do the engraving. We'll see that here. Let's run the engrave process, run a simulation. There it is, automatic. You do again have access to the nodes, and you've got options. Where's the upper tool when it does this? Where does the ASP carriage move to? Where will the manipulator be? What's my upper tool in position, and so on. And all of those are again in this engrave dialog box, and you've got a lot of options to correct, much like the other features that we've seen. So the bend is engraved. Next step is to bend that angle up to an angle that's not finished. So let's come back and look, make sure we're getting the right side. Select this bend, do a standard bend. Okay. Let's take it to, let's watch this, 60 degrees. And then add a standard bend after that, the last bend, to 90 degrees. And run the simulation. Make sure collision detection is on. That's all good. We'll come from the engrave, and we'll do a run on from the engrave. It scores it, bends it, underbent. We do have a crash here. So let's just look at that. It's just touching. We have two options here. I could increase this angle, or I could tell the upper tool not to come up as high. Let's take a look at that. So this upper tool, the standard bend, this is the this one, upper tool out position. So the upper tool goes to a position when the part is coming out. We'll change this upper tool out position, and I can say just come a little bit lower, as long as we're not catching the material. And let's run that. Fine, no collision, no crash, quite tight. I got this as bent over as far as we could. What's the next step? Very similar to what we did with standing seam, but instead of using the blade, we're going to use the upper foot to do the crushing. So we'll add a standard bend. I've got one bend left that's not finished. That's the bend that needs to be done. We'll add a free bend. Okay. And now I have control, and I'll expand my free bend tree and get to the free bend node. First things first, I need to move the part forward. So we'll do a manipulator move the manipulator. I can mouse wheel over this position, remember that, and just get it out of the way. This green line from LBN is quite useful to know how far forward to go, so that we clear it. Hit enter. Then I need to add an upper tool move the upper tool, click and drag and grab it out of the way, not too far. And then I need to add a manipulator move the manipulator, and drag this back over the working table. So we're going to come to about here. Now, something to note, our upper tooling, if you have an AUT machine, so BC Smart doesn't have this and EBE 3820 doesn't have this, but there will be a groove in the tooling that allows the AUT tool to lock in there. So be aware that if I came down to crush it, I don't want it catching in the groove. We want to do the work kind of here. So that's stored. Next step is to take the upper tool down to touch the part. Just close, hit enter. And then finally, we're going to take it down to the position that closes this part. Now you could add 1, 2, 3 steps if you want to have a bit more fine tuning. One is okay for us in terms of training right now. So we'll add an upper tool move. Open this dialog box to change the angle. The angle now becomes 90 degrees. And now move the upper tool to close the part. Close enough. And again, at the machine, you'll fine tune that location to make perfect parts. Last step is to add an upper tool move to open it back up again. Just once we're done bending, we need to be ready to do the next bend. So we'll move that up and record it. And that's the free bend done. So let's run the whole process from the beginning. Negative bend, offset bend, finish it, score the part, underbend, 90, squash bend, and that's a tube. Okay, so tubular bending is very useful for making stiffer panels, adding rigidity to thinner materials. The XY bending that we saw was quite interesting. We have another application for that coming right up. So XY bending, or this offset bending, is very useful in terms of what we call indirect bending of the sheet metal. Let's take a look at that. Back to NC Express. Let's bring our folder in. And we're looking for this XY bending part. Let's take this in. Okay, put it away. So we have a part here that's going to be difficult to make because we've got an up and up, and then we need to bend it down and get back up again. But we're going to find that to do the down bend, it's blocked by this flange. So this is going to be quite interesting. Let's unfold the part, file, and then file export. Come to MasterbendCAM, bender process, new. Let's take our machine and XY bending. So let's see where we have the problem here. Let's just say okay and okay. So what we're going to do is we're going to fast bend the side completely just to see what our issue is. Seems straightforward, up and down bends. Let's have a look. And we're going to see where we have an issue here. So let's run our simulation and we'll see where we have the problem. Here comes the first bend, positive, positive. Now how do I get to this negative bend? You can see that this is hidden. So in the past, we would have brought in an AUT tool that would sneak under here and pop it down a few degrees. And we would have had to do a lot of free bending to kind of get this part down. But what's nice now with this XY bending is we can put the offset in and actually bend this bend from up here. And you'll see that happening here in this video. Okay, so this bend is bend number 3. 1, 2, bend number 3 is our problem bend. We come to pick the standard bend. And what we're going to set here is the XY position. So right now the bending it wants to happen here. We're going to tell it to happen right up here instead. And record. So all I did was grab the C frame, drag it up and hit enter to store that position. And if we look at the dialog box, we can see that XY bending, by doing that, is selected and the Z offset is set. Now let's simulate that. There it goes. And that matches what you've just seen in that video. So very quickly, very easily, we're able to do these bumped and nudged bends. Very useful for complex flanges that maybe need to interlock. Very popular with the building facades or cladding companies. We see this quite a lot. Then the next bend should happen, and that's fine. So from start to finish, run the simulation. positive, positive, XY offset, positive. Perfect. Okay, so panel benders aren't always all panels. We're able to make narrow parts on the panel bender with a feature called bend breaking. There's two ways of doing bend breaking in our machine. We can score the part for the break, which is using a wheel that'll pinch the part top and bottom inside the panel bender. It's also possible to do that in the punch press with a wheel tool there. So you can take the cycle time that's needed to do the scoring out of the bender and move it into the punch press and get a faster throughput of parts if you're doing a lot of these. So let's take a look at the bend breaking part. So again, in NC Express, what we're going to do, we're going to bring in our folder and just look at one part. So grab the bend breaking and bring that in. Now let's put that out of the way. So what we have is a Z channel. Okay, this is a narrowish channel. It's a longish part, it's about 60 inches long, and these Z channels are about an inch, inch and a half. And what we want to do here is we want to create a PFP file that has several of these grouped together. So we're going to do a little work in NC Express to create this part. So the first thing we're going to do is unfold it and come to File. And once we have this part here, we're going to come up to CAD, and we've got that up here with our drawings. And we have this ACP, or Advanced Cutting Programming part. Okay, so with ACP selected, so up here we'll put in the number of pieces that we want, type 6, and hit enter so that that's stored. And then we're going to have a manipulator strip, and that's a waste strip on the group of 6 that the manipulator has something to hold on to. And we'll hit create. And there's my 6 parts, and you can see them 1, 2, 3, 4, 5, 6, and then the manipulator strip is held at the bottom. Let's close that and File, Export, and save the PFP. I'm going to call this one, this was our bend breaking part, save. So we'll go to MasterbendCAM, Bender Process, and we're going to go to a new part. Now we're going to assume that the scoring for this part was done in the punch press. So all we need to do is the breaking process. So you'll see a video of that happening here. Okay, let's program this part. So in MasterbendCAM, we're going to pick our machine, and we're going to pick our bend breaking file that we've made. We're going to pick the base face as being this manipulator strip. And the other thing we're going to look at is right now it's going to do an up bend then a down bend. I want to flip that. I want to do the down bend then the up bend. So we're going to change the part to being upside down and say OK. I'm going to rotate it so that the bends are coming into the machine. This is the way it's going to be stacked before coming into the machine. And let's start by adding a single process. So we'll come to automatic bend sequence, add a single process. Let's add our first bend line as a standard. Okay. Now we're going to add a second bend line, but what we're going to see is that there's going to be a collision here. So I'm going to do a free bend ultimately, but let's have a look at this part from the side, and you're going to see what's happening. So if I push play on this one, you'll see that the tool doesn't exactly fit. And much like what we saw in the video, we want to do is we want to nudge this to about 20 degrees and then come in and finish it. So what we're going to do is add a free bend here instead. So we'll delete this standard bend and add another process to this bend line, free bend. Okay. And much like the others that we've seen, we're going to move the tooling around. Actually, before we do that, there's a piece of information we needed, and that would be where the manipulator goes to make this bend work correctly. So let's let the software do the work for us. We've got this properties panel that's giving us a lot of information, but what I'm looking for here is the man P position. So we'll go to the information of the standard bend and see that the man P position is at 520.51. Let's write that down, 520.51. Now what we'll do is delete that bend and add our free bend. So we'll come up here, add a free bend. So what we'll do, we'll come to our free bend and add a manipulator move. And we remember our dimension from the bend that we needed. So we can actually come up and type it up in here. 520.51. That's where we wanted that. So now, once we hit enter, that's stored. We're going to add an upper tool move and take the upper tool down to touch the part. And then we're going to add a move, C-frame move, and bring the C-frame up close, like here, record it. And then we're going to add another move, C-frame, and then take it just to touch. Make sure we're in a good position here. And then we're going to add another move, change the angle. We're going to allow it to bend to about 15 degrees here. And we're going to take the C-frame and put it in contact with the part again here. You could have added intermediate steps if you liked. Let's run through this free bend. We'll select free bend and push play. Okay. Next thing is we want to move the upper tool or the lower blade into a bit of a better position. So we'll add a linear move, grab the C-frame, drag it down a little bit and over here so that it's got a clean trajectory to come up into the next bend. So this is a good location. Record it. And now we'll add a standard bend to finish that bend, which is here. Let's just look at the isometric. This one here, standard bend, and finish it. Okay. So let's run through the full simulation now. We almost have one part complete. Negative, rebend, and finish. Next step is to add the break line. So again, we're saying that in the punch press, we scored this part already. And all we have to do is break it. But in order to get the part out of the machine, we need to add the paddle that gets attached to the ASP bracket. So we're going to go to our engraving tools, and we're going to select the right-hand ASP here and do UCP, or Unload Cut Profile. And the Unload Cut Profile has this paddle that'll push the part out once it's been broken. Okay, so the next process for us is to add the bend breaking. We'll add a single process, and in our case it's going to be bend number 5 is the first one here, this first bend break. We'll select bend breaking, okay, and it's going to ask how is it being unloaded. We're going to use BCP left, or BCP, which is on the right, and that's the one we installed on our ASP carriage. So with that added, we can see the bend break line is happening right here. We'll hide our C-frame and take a look from the back so we can see the whole process here. Go to isometric view and rotate around. Okay, so from the top, let's do the full simulation. We have our negative bend, free bend to 15 degrees. Finish the standard bend, and then in comes the paddle, do the bend break, and it pushes the part out. Now the nice thing is that's the end of the process. So Tubular at the panel bender will take care of the next 5 parts fully automatically. It's all taken care of. So bend breaking is fairly easy. We just have to teach it to do one part, and Tubular takes care of making repetitive parts after that. So the last thing we have to do is parametric programming. So we'll go back to our simple 8-sided part, show you how to make a parametric with Parametric Onboard. So we're back in MasterbendCAM. We don't need to do anything right now with NC Express. So what we're going to do is go to Bender Process, do a new part, and we'll take in our 8-sided part, pick the right machine. You say okay, okay, and we'll just auto bend it. We'll do here short side cycle and create our program. Now, Parametric panels means that the base face of the panel is changing, but the flanges are staying the same. So this is simple XY bend changes that you can do at the machine. The operator will have MasterbendCAM at the machine here. This is an option that needs to be bought for the software. So once we've got the part made, we can select the bender process, just run a quick simulation of it. Part comes in from loading. Tooling is set up. Centering is done. One short side. Then the other short side. And one long. And the other long. So we've made this part, but instead of having to make new PFPs or go back to CAD or have your engineers make new panels, if the base face is the only thing that's changing, in other words, I've got longer or wider versions of this panel, we can use parametric programming. So that's this button up here in the top right that needs to be enabled. And what we're going to do here, we have a few things. This reference PFP, what this does, this will reference some other panel or main panel that we've made, and will copy any of the bend corrections from that panel that's existing over to all of the new panels. So that's quite useful if you want to keep your corrections coming in too. So what we'll do here, let's give it some new dimensions. So we've got a 688 millimeters wide. Let's double that. Let's make it a bit bigger. We type in the number and hit tab, and let's make it a little bit wider in the Y. Let's make it 600 in the Y. And once we say OK, it starts to make the new part and the new program fully automatically. Now, one thing to pay attention to is that we have to respect where holes are in the parts. Shrinking a part that already has a hole pattern in it could give us an alarm, but we have the option to delete the holes out of the solid model before the part is shrunk down. So for the most part in a panel bender, we're not as much concerned about holes in a panel or holes in a part as we are the formings and the flange heights. So once all of that's done, we get a good panel anyway. The parametric is now executing from this original mother part, and it's also going to do full cam. So by doing full cam, it's also checking piece collision, part collision. If you've got a simple panel like this that we know works perfectly and we just want XY different versions of it, it's also possible to make parametric parts by using a script. Script is incredibly fast. It's essentially going to make a copy paste and just do some mathematical calculations. But in this case, it did a full cam. So here's our new panel with our new dimensions. Program's already made. Push play and see the simulation. One short side, the other short side. Again, because everything's nice in 3D, we can rotate our view around and zoom in and see what's happening. That's the panel done. And the nice thing now, when we save this panel, hit save, it takes the mother name that we had, simple 8 bends was the name of the file, and it adds an underscore, the X dimension, Y dimension. So this is a nice way of keeping all these panels separate. So you can see I've already got a few extras in here. I've got a 600 by 500, a 2 meter by 1 meter, and all of these get saved with the suffix on it. No need for the operator to come up with a new name for it. It's all automatic. Well, that's MasterbendCAM in a nutshell. Your applications trainer will go through more details about how to apply this actually to your materials, your process, your parts. This is enough to equip you with the basics so that when our applications trainer comes out to see you, you've got maybe some good applications, some good questions. How do I apply this to my product and so on? So good luck with MasterbendCAM. Hope you enjoyed the video and see you next time.